today's first Friday. Just a few reminders before we get started. In the email that you received where you signed up for today's webinar, you got a link to the handouts and a link to the quiz. If everyone could please complete the quiz no later than Sunday evening. That way I can grade your quizzes early next week and get PDH certificates to you at the end of next week. Just a couple of other things to keep in mind. This is a renewal year, and most of you are regular attendees of these First Friday webinars, but if you are looking for PDHs, we will be holding our annual boot camp, or every other year boot camp, where you can earn all 30 PDHs that you need for your licensure. That will be held October 6th through the 9th in Springfield at the Northfield Inn and Suites. And more information about that event will be coming out here in the next week or two. I will go ahead and turn things over to our presenter today. Our presenter is Mr. Zeyn Uzman, two-time past president of ISPE, and he will be talking about the work that his students have been doing in Panama. So Zeyn, all yours.
Thank you, Courtney. I hope everybody can hear me. I started teaching. I moved to Philadelphia about 7 years ago now, and I started teaching at Villanova about 6 years ago. And I'm also practicing engineer, so I bring the practicing part of engineering to the school. And the class that I teach is their senior level capstone class, which is a design project. Because Villanova is a Catholic university, they're dedicated to not only educating their students, but also having them do service projects. And they're very fortunate in the fact that they have the opportunity to do projects all over the world. The students will make trips about 3 times a year. They'll go on their fall break. Some of them will go on Christmas break. Some of them will go on spring break. And also some of them will, 1 or 2 will spend the summer interning in one of these locations. And I'm going to talk about the projects that we worked on in Panama this past year. Mostly in my classes, I teach a structures capstone. I teach one in building design and one in bridge design. And we had 2 chapels to design, one in Panama, one in Honduras, and then we had 2 bridges to design in Panama. So right now, through the university's engineering department, we are actually working on the design and construction of a orphanage in Cambodia, and next year a school. In Honduras, in the past, we've worked on an orphanage with a lot of their building, and this year, as we speak, under construction is the chapel. And then, of course, in Panama, as I said, we're doing chapels, water distribution systems, bridges, and next year we'll be designing a school. So with this, what the program that Villanova has set up is engineering service learning, and it's similar to Engineers Without Borders, and they actually have a chapter of Engineers Without Borders, but it's not as active in doing these projects as their engineering service learning. And this is funded by the university. The students have to pay a nominal amount for travel, but it's sanctioned and funded by the university. So what I'm going to talk about today is the projects that have been done in the past and are currently ongoing in Panama. And it's infrastructure in the Alto Baño region of Panama. There's 3 types of projects that we've been working on. One is water distribution networks, some chapels, and some bridges, as I've stated before. Who we're doing all this work for is Father Wally. And Father Wally is one interesting character, and there's a picture of him in the lower left-hand corner. Father Wally's on the left. Professor Frank Falcone is on the right. They have been working together for over 20 years. And Frank's been going down there for 20 years, helping him with the water distribution system. Frank is primarily a water resources guy. The bridges and chapels have just started in the past couple of years once I started getting involved with the design. And when I say Father Wally is an interesting individual, he is quite an interesting individual. He was born and raised in Michigan. He's got a degree in theology from St. Francis School of Pastoral Ministry. He has a law degree from the Antioch School of Law in Washington, D.C., and he's been very involved in the promotion of human rights in Latin America, and he actually worked on the Panama Canal Treaty. And we went down there beginning of March and spent a week at his place. And give him a drink or two, and the stories start, and it's amazing on the things that this man has worked on. He's worked on the Karen Silkwood case and a few others, so he's got a very diverse background. He was in Wisconsin, and he was assigned in 1988 to Wacu, Panama, and it's a small rural village east of Panama City. And his mission was both to bring religion and spirituality to the area, but also to work on the infrastructure. So once he got down there, he created a construction company that employs numerous people in the area. I would say when we were down there, he would have a crew of about 30 guys going around working on various projects. He does the water distribution system. He builds churches. He has built most of the roads except for the Pan American Highway in the area. All of the bridges, all of the water distribution system is his. And he pays his employees much better than what the local people pay. He pays his guys about $30 a day when the average working salary is about $10 a day down there. His operations, head of operations is in Tortilla Panama, which is where this location is. This is Panama City. Here's the Panama Canal. And Tortilla is a very small town in Panama. They have a grocery store, a gas station, 2 restaurants, and that's it. And if you blink, you'll miss it. He has a compound there that he has construction equipment where he has his workshop. He also has what is called the dormitory because he has students not only from Villanova but from other universities all over the country that come down and actually help him through the year. And you can see this is the border of Colombia, and we're really close to the border of Colombia. This gives you an example of the equipment that Father Wally has. All of his equipment is donated. He either, once or twice a year, he gets a container shipment from the United States with equipment, with materials, whatever he needs for construction. And his tortilla is approximately 2.5 hours drive along the Pan American Highway from Panama City. So he doesn't get to Panama City that often, and so everything gets trucked in that he has. All of his workers, he's trained himself, and most of the stuff that he's done is self-taught. So over in the past 3 decades, Father Wally has completed these projects: bridges, culverts, roads, buildings. And among these buildings are chapels and schools, and then 5 water distribution systems that serve approximately 5,000 people. Now, when he got there in 1988, nobody had water unless you dug a well. There was no clean drinking water, and there were very few people that lived in the area of Tortilla. His construction of a water distribution system has greatly impacted the quality of life of the people there, which has actually caused more people to move into the area. This gives you an example. This is a map of the region where he lives. All of the blue lines here are water distribution systems that he's put in. Those are bridges that he's built. There's a dam that he's built here. The entire water distribution system is gravity feed, except for the new one, which we're working on right now, which I'll talk about later. Most of this area here, you can see all the blue lines are contour lines. So you can get an idea that everything in the left here are contours. It's very mountainous, steep mountainous area, and then it flattens out. All of the area to the right is pasture, farmland. All the mountains are pretty forested with lumber. And one of the things that's happening in this area is one of the woods that's very prevalent there is teak. And so there are people going into the mountains and harvesting the teak wood. And matter of fact, while we were there, this line down here was broken by the foresters. They actually ran over the line. Now, what you see when you get there, it's not like what we see here in the United States. The water distribution system essentially is a 6-inch or 8-inch PVC pipe that's laying on the ground. It's not buried very much. So what happened in this area is we had a truck run over the pipe and break the pipe, and we'll talk about that a little bit later. But as you can see, all of this is the projects that he's worked on. There are, like I said, 5 gravity systems that he's worked on, and Villanova engineering students essentially have designed all of the systems. Sorry about that. I'm trying to get that so it doesn't pop up. While we were down there this past time, the Canassa system was the main focus, and that is the system that on the previous map here is that you saw coming through here. This is the dam that was designed by Villanova students, and then there's the water distribution system. Right now we're upgrading the system that currently serves 5,000 people and 13 communities with potable water that has pipe over 100 kilometers long, scattered all over. We're looking at increasing the capacity. Now, one of the questions you may have is, what is the quality of this water? We have actually designed in the system water purification, and when our students went down there in March, the first thing we do is we do a settlement test, and we do test to check for chlorides and all chemicals and bacteria in the water. And we found that the water is still very clean and drinkable. As a matter of fact, when we were there, that's the water that we would drink, and nobody got sick. This is a picture of the dam at the head of that water distribution system. And this dam serves approximately 16 kilometers, or is located about 16 kilometers from the Pan American Highway. As you can see, this is the dam down here, and this was the second dam that was constructed. The first dam was constructed way back here, and the capacity of the reservoir was such that we could not service enough people. So what happened is it had to be expanded. And this dam was built in 2004, but we didn't start construction, or designed, but we didn't start construction until 2009. And since 2009, every year he adds concrete to it to extend it up and horizontally so that we can get more water. Now, one of the things that you'll see here is the water level looks really low, and we were pretty much at the end of the dry season in Panama. Panama has two seasons. One is the rainy season and the other is the dry season. And the rainy season starts around August. So we were down there, or excuse me, starts around June. So we were down there in March, and you can see what the level of the water is. Actually, during the summer, the water system will dry out, and then what he has to do is truck water in from other sources to get water to for his system. And he actually trucks it to the different villages, and I'll show you a picture of that later. So this is the pipe coming from the dam, and you can see here these are overflows, and you can see all the construction showing. Every year he'll sit there and just add a few more feet to the dam so that he can increase the capacity. Now, downstream of the existing dam, we've been constantly having pressure problems. As a matter of fact, when we were down there, one of the pipes had burst, and you can see our students helping Father Wally's crews repair the pipe that was down there. Our students right now from Water Resources are working on a pressure relief valve for Father Wally and a system to reduce the pressure. Father Wally has been doing this long enough that he has enough knowledge of what needs to be done, but what our students do under the guidance of Professor Falcone is to actually design what the pressures are, what the equipment that's needed, and then give it to the specifications to Father Wally, and then he acquires the materials and puts them in. The other thing that, in addition to the brake pressure tank, our students are also working on a sedimentation tank to remove the sand and the debris. As you can see from that picture, the soil in this area, I mean, it's a dam, and it's getting runoff from the mountain. And there's a lot of sand and other debris in it, and in order for it to settle out, we're adding some sedimentation tanks. Towards the eastern end of the water distribution system is a small Indian village of that is, when we were there, was out of water. This is the area where the pipe had broken. And so, to give you a little background, Father Wally has set up this entire water distribution system, but he's also set up a commission that oversees the operations of all this, which he is on the board. And they actually collect money from everybody to pay for their water. And he'll go to the villages once a month, and the villages are responsible. Each village has the responsibility to collect the money. And if people do not pay, then he will cut the water supply. And as you can see in the picture to the left, these are actual water meters. It's a small PVC pipe that comes into a pit that's got a shut-off switch here, and then it's got a meter box here, and it goes to the resident. And in this area, the typical residence looks like this. Like I said, the people in this area here had been without water for 2 weeks, and every couple of days he had to come in and truck water. Excuse me, every week. Now, you may ask what happens if somebody doesn't pay. Well, if somebody doesn't pay, the first thing he'll do is shut off the water in that little box. And after a month, if they still don't pay, he actually takes a hacksaw and cuts the PVC pipe so that they don't have water anymore. And then he charges them a steep rate to have the pipe reconnected. Panama, the area where we were, this is one of the Indian villages. This is typical of how they live. It's on stilts. A lot of the other areas, the residents and the building construction essentially is cinder block with metal roofs, depending on which village you are in. 90% of the people in this area are either raise cattle or they're farmers. Unlike the city of Panama City, this country of Panama is there's two different Panamas. There's the Panama City, which essentially is part of the Panama Canal that the United States controlled for almost 100 years. And then there's all the Indian villages outside. And this is typical of what you would see in the Indian villages. Now here you can see the truck that once a week he would bring water out to these people, because even though the pipe was broken, these people still had to have water. And this was a 8,000-gallon truck that he would bring in, and you can see all the 5-gallon pails that people would the truck would fill them up, and each hut would get 5 or 6 of them. And you can see our Villanova students helping trucking them in. It was a heck of an experience for our students because they got to see how people live, and it was it's different from them where they live on the outside of Philadelphia in the northeast part of the United States, having the cell phones and everything else. Where we were, very little cell service, no internet, no television. It was quite the experience. Now, another distribution system that was in the process of being designed while we were there is the Pignati in Panama system. In 2012, by accident, one of the farmers was digging and found a groundwater source. And he told Father Wally about it. Father Wally sat there and said, okay, I can come up with a system for you. And right now the area has no supply of clean water during the dry season. So with this well, he was going to be able to provide water to them. All he did with the well is he dug a well 20 foot deep, put a PVC pipe that was about 24 inches in diameter, drilled a bunch of holes into it, shoved it in the ground with concrete or crushed concrete, and cemented it in place. And this one well is approximately 1 kilometer from the main storage tank for the community. Previous to this, what he was doing was trucking water in. So what our students were doing was designing a water distribution system from the water tank to approximately 20 residents in the area, and a way of pumping this water to the storage tank. This water system will be the only one that has a pump to it. All the other systems are gravity flow. And you can see on the left-hand picture here, there's Father Wally, there's some of our students, and this is the existing platform that's approximately 10 feet in the air, and this is the water tank that is going to be hooked up to the distribution system. Now, with the addition of the pump, we're going to add a second tank up here and pump the water up and have more created heads. So therefore, what we'll be able to do is have our system go to more residents. And what our students did while we were there is, this is the existing tank, and we sat in the back of the Jeep and designed the addition to this while we were there. We calculated out how much the tank weighs, how thick the slab had to be, how big these columns are, and essentially came up with a sketch, gave it to Father Wally, and his guys, as you can see, here's his guys standing there. They were waiting for us to tell them how to design it. And the students that go here are seniors, juniors, sophomores, and freshmen. So mostly the seniors and juniors are doing the design, and the freshman and sophomore class essentially is there to learn everything that's going on so they can eventually take over the design of the additional parts of the project. Now, one of the things that Father Wally's mission was for him to spread the religion, the Catholic religion in the area. And so what he has done is he has constructed a lot of chapels in the area. And a lot of these chapels hold 15 to 20 people. They're very small. They're the one that you see on the left, which is currently under construction, the one on the right, which is finished, probably are 30-foot diameter, 30-foot square, maybe 45. And the thing that's interesting that we learned down there is the construction methods are totally different than what we would see here in the United States. And so our students go down there and they see what we're doing or how they're built, and they have to change their design to meet how the methods of construction are. And the way they design them is, first of all, it's in Panama, and the temperature doesn't really vary much more than 20, 30 degrees throughout the entire year. There is no frost, so you pour essentially a big mat foundation slab, and then what they do is they construct the block walls, and these block walls are 6-inch CMU walls, and then these are openings, and you can see the openings over here. So they build all the walls first, and you see these voids here and here. That's where the columns are going to be for the steel framing for the roof. After the masonry walls are in place, then what's done is the concrete is poured in those voids, and then a concrete ring beam is poured all the way around. And then the roofing system essentially is metal deck and light gauge metal beams that are attached to the concrete. One of the other projects that the Villanova students worked on in 2004 is they helped actually design and construct this chapel near Tortilla. And this chapel is really the main community center for the area, and Villanova students still go here and help him out. They helped him work on the addition to the chapel here. And again, what the students do is they get the information, they design them as part of their class, send him down, and he does the construction. Again, these are the chapels that our students were working on, and you can see here's the masonry block, here's the reinforcing for the columns, and then you can see this is just light gauge metal. And it was quite an experience for our students because they're used to seeing construction projects around here, and the way they do things down in Panama are the methods and the means that they have are limited to what we can do here in the United States. And so what they have to do is understand what his availability is of materials and his construction methods, and design something that's going to be structurally adequate to take the wind loads and the seismic loads that are required in the area. Now, one of the things that you'll notice here, this is a cross. It's essentially part, and then all the windows are the same block. They have no glass windows down there. Matter of fact, most of the residents down there do not have glass. Everything is just open air, and they may have screens on it to keep the bugs out. But you can see on the right here is our roof construction, metal deck. These are maybe 8-inch metal studs that are welded together to form a beam. And he does everything with light gauge metal. Very rarely, except for the major structures we saw before, he'll use steel. Now, the other thing that's very interesting is how he makes his concrete. For his chapels, he has fine and coarse aggregate, and this is what it looks like. And it's definitely not something that you'd see at an IDOT site. This is just piled up fine and coarse aggregate, and there's a lot of silt in there, and you can see that they just dump it into a wheelbarrow, and then they put in cement and water, and this is the mix that they use. It's 1 wheelbarrow of aggregate, 3/4 bag of cement, 5 gallons of water, and they just hand mix it, and this is the concrete that's used for the chapels, for the beams and for the column. So our students went down there, and this was 2 years ago. They went and actually had them make concrete for them and made cylinders and brought them back from Panama to Villanova, and we did testing on them. And this is the result of our concrete testing. And you can see that our cylinders, we brought back 5 cylinders with us, and you can see what the failure stresses were. They range between 2,500 and 1,800 PSI. So based on this information, now our students had to use this number to design all their concrete for the chapels. And based on this information, we used 1,500 PSI as the allowable concrete strength. So that's right now our students are designing we're designing actually 3 different styles of chapels that we're going to give to Father Wally. One is a square, one is a hexagon, and one is a circle, and he's going to use those in different communities. And these chapels are used for community centers, for people to get together, and they're also used during religious Sundays and other religious holidays to practice Mass. Now, one of the things, like I said before, Panama has a dry season and a rainy season. And we were there in March was the dry season, which was very fortunate because you could get around. There are locations in Panama near where he lives that during the rainy season, entire villages are cut off from civilization. So what we have been doing at Villanova for the past few years is designing bridges that he can construct. Now, what you see on the left here is a low flow crossing. This stream here that you see here, you could walk across this stream and drive across it during the dry season. And once it starts to rain, the water would fill up. And not during the heaviest rain, but for, I would say, about 9 to 10 months of the year, you could get by through this. This system was designed by Dr. Frank Falcone, probably about 18 years ago when he first started going down to see Father Wally. And essentially what it is a bunch of 24-inch or 30-inch diameter pipe culverts and then concrete that's poured on them, which works very well for most of the season. But what ends up happening is debris will get hung up in there, and then you start getting scour problems and erosion, and I'll show you a picture of what happens with that in a second. On the right is a picture of the first bridge that was designed back in the 90s by Villanova students, constructed by Father Wally. And this is a major gully, and actually, if we continue down this road, is where that well that I showed you the picture of the water distribution system a few slides ago is. During the rainy season, the water will get up to just below the beam. So that gives you an idea how much flow comes through here. He works primarily on donated equipment. Everything donated equipment and materials. And what he did with the help of Villanova students is design these concrete columns up here, and then these are precast T-beams that somebody donated from him that you would see at a parking structure. And then they designed it to be a composite system with a composite deck and poured concrete on it. And like I said, this one is probably around, I want to say 15, 18 years old. As you can see, there's no railing on it or anything like that. We design everything to AASHTO standards as far as loading, but some of the other criteria not necessarily is a high concern. They're happy to have roads and bridges, and I'm sure the question of liability will come up during the Q&A system, and we can talk about it then. So last year, what normally happens is 1 year the students will survey it, and then the next year during their senior level, their senior year, they'll actually do the design. And this is last year's students that are actually doing surveying of the sites for the bridges that we designed this past year that we're going to go over. The students actually, it's pretty impressive because unfortunately, I don't know what it's like at other universities, but at Villanova, surveying, the only surveying they get is 2 weeks of surveying in a fundamentals class. So these students do pretty well. They do not use total stations. They use the old form of surveying equipment, and they're able to survey the sites enough that we can do the design. Now this year we had 2 projects that we worked on. One was the Rio Hira, and the other one was the Rio Venado. And you can see that the bridges, the openings from peak to peak, on this one was about 450 feet, and from this one and from peak to peak was about 250 feet. We did not do any hydraulics design on it because we could not get enough cross sections and could not get enough information from the area to do hydraulics. But what we did is we talked to essentially area residents and said, okay, how high does the water get? During the rainy season, the water gets around 97. So you can see how high the water gets and what kind of crossing that we would need. The other limitation that we have in Panama is roads. And you can see on the left, this is a typical road in the mountains that where we would be placing a bridge. And this is the location of a bridge that was designed last year. This is the road going through the stream. The new bridge that they designed last year is going up here, and it's actually under construction. So this is one of the 2 sites that we're designing a bridge. And this is those pipe culverts I talked about before. This is what was there, about 300 foot of it. There were pipes and concrete, but as you can see here, a bunch of logs and everything from the people logging, debris comes down, clogs up these, and everybody knows what happens as you clog up a culvert. The velocities go up and it starts scouring out. And this one, about 2/3 of the low water crossing was scoured out. So our students this year wanted to get an idea what the site was like, and you can see this red line here is approximately where the high water is. That's approximately 97. Now, like I said before, Father Wally gets a lot of his stuff from donated material. And this year, we were very fortunate, or he was very fortunate. Some of you, I don't know if you're aware of it or not, but there's a major expansion going on to the Panama Canal right now. And somehow there was some change of design, and there was approximately 3 million pounds of beams that were not going to be used. They're already shipped down from the United States and sitting in Panama City. And the Ministry of Public Works, who has known about Father Wally's work for many years, has said, look, I'm going to give you the opportunity to use these beams wherever you want. So he sent the list to us, and we instructed our students that, okay, this is what you have to use. And you can see on the left-hand side is the size, and this is the length, and this is how many he had of each of those lengths. And the beams were not what we would consider typical beams for bridge construction. I mean, in the United States, the smallest beam you would use would be a 24-inch beam, and very rarely would you use that to a plate girder. Here you can see we had 18 21s, and then there were some 24-inch beams. So our students, we had two groups of students working on this, on the two bridges, and they had to work independently but also work together off of that list of beams. And this is the smaller of the two bridges. So this one was the one that was about 250 foot long. And once you put the high water in, they had to build the bridge a foot above what anticipated high water was. And based on the beams that they had available, this is the initial design that they came up with. Two spans of 52 and one of 60. Try to center it in the stream and try to keep it out of the stream as much as possible so debris didn't take down the walls. And then we would have them fill in the approaches. And this is a typical cross-section of the bridge. And this was W21s by 73s. This was non-composite construction. And we did not design for HL93 loading, which is ASHTO, but we designed for an H20 truck, not an HS20 truck, because that's typical of what you would see on these roads. Essentially, what the vehicles that are on these roads are Father Wally's trucks and maybe cattle trucks, and that's it. And again, we tried to make the project as simple as possible so Father Wally could make it. Now, we could have gone composite, but Father Wally does not have the means of making these beams composite. He does not have the means of welding shear studs on, and the other possibility would be to weld channels onto it, which ASHTO allows you to do, but we just did not have the the capability to do it. So when I was down there with Father Wally in March with my students, we actually met with the Ministry of Public Works and showed them the preliminary design. And what is so good about the class that we teach is they're designing real life projects. And you can see there's Father Wally and myself, and you can see where the crossing was here that we were building the bridge. And what happens when you do a preliminary design and submit it to the client, then the client's going to say yes or no. Well, we met with them once they got to the site and they realized our preliminary design was too short. The 60-foot span was too short. They wanted to clear span everything, the stream. So they came back and directed us to redesign it. And this is what our new design was. They wanted 2 feet of clearance from the high water to the bottom of the beams. They wanted us to clear span, and we actually when we met with them, we decided on the 80-foot span, and then we had 40-foot span as approaches. We were able to use some of the steel beams for the approaches, but this in the center were now custom plate girders. So they had to redesign everything after halfway through the semester. And this is the final plate girder design that they came up with. Again, this was a non-composite design because of the limitations of what Father Wally has. So that pretty well gives you an idea of what our students at Villanova have been working on in Panama. And at this time, I'll open it up to questions.
Thanks, Zeyn. We've got our first question in. Do you have to be concerned with earthquakes and hurricanes in designing your projects?
That's a good question. In Panama is not, we actually look at the seismic acceleration coefficients and we look at the wind loads in that area, but where we are far enough away from the coast that we really don't have to worry about hurricanes, and the seismic is actually not as high as, say, in Honduras or El Salvador, places like that. But we do take that into design.
I haven't received any other questions. If you have questions for Zeyn, if you could type those in and we'll get them answered.
Okay. Well, one of the questions that I have talked about this before while we're waiting is liability, and what liability do we have? And really, we've been doing this for numerous years, and because we're doing it as charity work, we don't have to, or we don't worry about it. And the other thing is, you got to remember, the areas that we're doing these projects, these people are thankful to have these projects. The bridge that we're working, one of the ones that I was showing you, 4 communities are shut off from grocery stores, for whatever grocery store you want to have it, any health facilities, access to the Panama Canal or Pan American Highway, and which is access to Panama City. They're grateful to have this. And again, we design our bridges to AASHTO standard, and very rarely do we see anything more than a pickup truck going across them. And that one bridge had no railing on it, and at one point it did have some railing that I really wouldn't call railing, but nobody's going to sue anybody nobody's going to sue Father Wally. Now, the one bridges that with the public ministry, those actually have to be designed to a little bit higher standard. But as far as the buildings and chapels, nobody's ever had any problem, with liability in our process. And Father Wally's thought process is, hey, I'm designing them, I'm building them. If something happens, I'll fix it.
All right. The next question, have village rain catchment systems been considered to supplement the dam and small reservoir?
We have looked into, there is some of those set up for individual houses, but not for the villages. That has not really been considered. And you got to remember, during the wet season, they're able to get as much water as they can or as they need during the dry season, and whatever they would be able to store themselves would not be that much. And the other thing is then each individual area would have to work on purification of the water. Like I said, this water is definitely drinkable. Like I said, when we were down there, we had no problem drinking the water or using it to brush our teeth or do anything like that. So that would be the only concern about doing that.
I haven't received any other questions. So, Zeyn, do you have any closing thoughts? Oh, wait. Oh, no. I just got a question about the slides and the quiz that was in the email that you received from me last night with the link to register for this webinar. If you are having trouble accessing those, give me a call here at the office. But that being said, there are no other, I haven't received any other questions about the presentation. So Zeyn, if you have any final thoughts for us?
Well, I think I'll just kind of close it with, if you ever have the opportunity to do anything like this, I encourage you to do it. I found it very rewarding to actually be able to work with these students, guide them in doing the design, and actually watch things get built and not have to worry about all the, people don't worry about all the bureaucracy and everything else that we deal with here. And if you ever get the opportunity to work with the young students and doing things like this, I highly recommend it. It's very rewarding. So thank you very much for listening today.
All right. Well, thank you very much, Zeyn, and thank you to everyone for participating. And we will go ahead and close things out a few minutes early and see you next month. Thanks, Zeyn.
Take care.
Bye-bye.
Bye.